get cover the most of the syllabus of the IP also, along with the and also competitive examination also, right. So there you can score a good.
So welcome back guys. Yeah, today is the session 4 of the questionnaire. So in this session now, like we'll start with the remaining questions of the AP sets. Okay, I guess I'm audible. Yes. So let us discuss the question number 102. Like yesterday we have completed up to 101. We will discuss the question number 102. Okay. Yeah, fine. Okay, let us read the question. The distance between the objective and eyepiece of an astronomical telescope when the final image forms at infinity is 62 centimeter. Okay, the first part of the question. And the second part of the question is like if the magnification of the telescope is 30, the focal length of an objective, like focal length of the objective and the eyepiece respectively, like what they have given in the first part, like they combined both focal length of objective as well as eyepiece, but in the second part they have given about the magnification. I need to find both focal length of objective as well as focal length of eyepiece, right. So let me take given things. So focal length of objective plus focal length of eyepiece, which is nothing but 62 centimeter they have given. That's what they mentioned, no, objective and eyepiece, right. Next, the magnification they have given. So magnification is nothing but 30. So by using these two conditions, I need to find what is the focal length of objective as well as focal length of eyepiece. Okay. So we know the formula for the magnification, right. So magnification formula is nothing but m is equals to focal length of objective by focal length of eyepiece, right. So we know that magnification is given 30. So let me take this as equation number 1. Okay, equation number 1. So 30 is equals to focal length of objective by focal length of eyepiece. So from this I can get focal length of objective is nothing but 30 times focal length of eyepiece. So let me take this equation number 2. So now I know, like I have got equation number 1 and equation number 2. From this equation number 2, no, I can put in equation number 1. So I can get any one term. So f naught, that is focal length of objective, is given, that is 30 times of focal length of eyepiece, which is nothing but plus fe equals to 62 centimeter. So this is 31 times of focal length of eyepiece equals to 62, where fe is equals to 62 divided by 31. Am I correct? Yeah. So this is 1 times and this is 2 times. So fe is equals to 2 centimeter. I will keep this one in a box. Next, by taking fe is equals to 2 centimeter, I can substitute it in equation number 1, right. So focal length of objective plus focal length of eyepiece 62. So focal length of objective plus focal length of eyepiece is 2 is equals to 62. So f naught is equals to 62 minus 2, which is nothing but 60 centimeter. So I got both focal length of objective as well as focal length of eyepiece. So which is 60 and 2 centimeter. Okay. This is about the question number 102. Okay. You can take a note of this. We go for the next question. Okay, right, we will go for next question. Question number 103. Yes. So, in an experiment, the angular width of a interference fringe for a light of a wavelength 5896 angstrom is found to be 3.5 into 10 power minus 3 radian. The wavelength of light for which the angular width of the fringe becomes 10% greater. So, we know the condition now. First, the condition is like angular width of a interference is directly proportional to, like theta is directly proportional to lambda, that is wavelength, no, lambda is nothing but the wavelength. So, initially theta is given as it is, but later theta become 10% greater, 10% greater in the sense that is, this is theta 1, let me take, like we need to know, like theta lambda 2 by lambda 1 is equals to theta 2 by theta 1. Okay. So, this is theta 1, initially it was theta 1 only, initial case, later it become 10% greater. So, 10% greater in the sense theta 2 is equals to, so 110 divided by 100 into theta 1. So, 1.1 times theta 1, am I correct? Okay. Now, we know what is lambda 1, right? It is 5896, right? Yeah. I know lambda 1, lambda 2 by lambda 1 is 5896, I know theta 2 also, that is 1.1 times theta 1 by theta 1. So, theta 1 and theta 1 will get cancelled, I can find easily. So, lambda 2 is equals to 1.1 times 5896. So, I will get what is the wavelength after it becomes 10% greater. Okay. So, calculation is your part, do it. So, answer is 6485.6. Okay. We will go for the next question, take a note of this. Okay. Let us move for the next question. Okay. 103, 104, yes. So, a proton and an alpha particle enters a uniform electric field perpendicular to the direction of the field, right? Okay. The ratio of the distance travelled by the proton and the alpha particle in the direction of the field after a time of t seconds they have given. Okay. So, I give a hint for this question, let us try it out. Okay. So, what they have given, like it is going perpendicular to the direction of the electric field. So, whenever a particle now enters the electric field, it makes a circular path, that thing you should keep in mind. So, I will write it here. Yes. So, in electric field perpendicular to the direction of the field. Okay. In this thing now, when it enters it will be in circular path. So, the distance I need to find. So, we know the formula, d is equals to half at square. Okay. And we know the formula for acceleration in the electric field now. So, A is equals to q e by m, q e by m, right. So, keep as it is. I can take this is equation number 1 and equation number 2. Okay. Take equation number 1 and equation number 2. You can take the ratios for this. Okay. You can take the ratios for this. They have given one thing is proton and one thing is alpha particle. Take a look of this question and try it out and tell me the answer. See, I can say q, q by m for proton, that is 1, is to, or I'll say Q by m for alpha, okay, which is directly proportional to, D is directly proportional to acceleration. This equation, this is the equation I need to take it. So, for this ratios we know. So, take the ratios and substitute the values, that is it. Okay, you will get the answer for this question. We will go for the next question. Okay, try it out guys, this question. Okay, question number 105. So, let us read the question. If a charge of 3 like under root 3 is placed at each vertex of a cube. So, each vertex of a cube which is of side 3 meter, then the electric potential at the center of the cube. So, we know the potential formula, no? V is equals to 1 by 4 pi epsilon naught Q by R. Q by R. What is the given thing here? Cube. So, cube of each side as 3 meter. So, from center to any vertex, let me take the distance as R. Okay. So, what is the formula we know? That is root 3 by 2 A times the side, root 3 by 2 times the side of the cube. So, from this I will get R is equals to root 3 by 2 into 3. So, this is one thing. Okay. Q, what is Q is given? Root 3, no? Q is equals to root 3 N C. Okay. So, take the value of Q, value of R, I can substitute it here. We know 1 by 4 pi epsilon naught is 9 into 10 power 9. So, 9 into 10 power 9 into root 3 nanocoulomb into root divide by root 3 by 2 into 3. Okay, you will get the potential. So, only the calculation bar is left. Okay. Okay, you can calculate it guys. After calculating now, we will go for the next question. Okay, I guess you got it. Okay, fine. So, look at the question, question number 106. So, if the magnitude of electric field in a conductor is 200 Newton per coulomb and the current density is 10 power 9, then the resistivity of the material of the conductor. Okay, they are asking about the resistivity of the material, right. So, what are the things is given? Magnetic field, electric, like magnitude of electric field is given, current density is given, I need to find the resistivity. Okay, we know the formula, no? Easy, no? So, E is equals to rho into J, electric field, resistivity and current density, right. I will write it here, electric field and this is resistivity and this is current density. So, what are the things is given? Electric field is given, E is equals to 200 and then current density is given, J is equals to 10 power 9. I need to find the resistivity. So, easy calculation only, no. So, 200 is equals to resistivity into 10 power 9, right, 10 power 9. You can calculate the resistivity, easy, no. Yes. So, next thing is interesting question, we will see that. Okay, we will go for the next question. Fine. So, what is the question is given here? If 20 watt bulb and a 100 watt
So I am very
100 watt fan, 20 watt bulb, 100 watt fan are used for 5 and 15 hours a day respectively, then the electrical energy consumed in the period of 30 days. Okay. So, the given things I will write it now. So, 20 watt bulb. So, for bulb I am writing used for 5 hours. And then for fan it is 100 watt used for 15 hours. See, these are the things is given for per day. So, 1 hour 20 watt, so 5 hours I need to calculate how much watt, and then 1 hour 100 watt, 15 hours I need to calculate how much watt, okay, and then multiply it by 30, easy. Like first thing, power is equals to work done by time we know, or else power is equals to energy by time. So, they asked how much energy consumed, okay. Now, we know that it is for 5 hours now. So, 20 into 5 I will get 100. So, it is for 1 day, 100 is for 1 day, 1 day. For 30 days how much it is? 100 into 30, right, which is nothing but 3000 for 30 days. This for the bulb. For the fan, so 100 into 15, which is nothing but 1500, this for 1 day. Next, 1500 into 30, I will get 3 5 15s are 45, 3 zeros, which is for 30 days. So, I got the power for 30 days for bulb as well as fan. So, energy, from this energy can be written as energy is equals to power into time. Okay, how much time also we calculate? So, 30 days. So, power also has been calculated, no. So, power into time we have calculated. So, energy consumed is equals to energy of fan, right, plus energy of bulb. Am I correct? So, how much energy? Watt into time. Okay, I will erase it. Okay. Now, E is equals to 4500 plus 3000. How much it is? 48,000. 48,000. So, I can write 48 kilowatt hour. That is it. This is the energy consumed. You can take a note of this. We will go for next question, okay? Yes. Okay. So, the question is given, two charged particle enters a uniform magnetic field normally. If the ratio of the specific charges of two particle is 2:3, then the ratio of time taken by the two particle to complete one revolution. So, one revolution they have given. So, what is the time period formula? So, it is T is equals to 2 pi m by q b, right? Okay. So they have mentioned that the ratio of specific charge. So I can take directly T is directly proportional to, like inversely proportional to Q by M. So specific charge has been mentioned, Q by M 1 is to Q by M 2, which is nothing but 2 is to 3, right. So T1 by T2. So this one will be down, like it will be, I will write it here, 1 by Q by M 1 by Q by M 2. So 1 by 2 by 1 by 3, which is nothing but 1 by 2 by 1 by 3, it's 3 is to 2. This is the answer. Yes. Take a screenshot or you can note it out. We will go for the next question. Okay. Okay guys, I guess you can answer directly without calculation for this question. So magnetic field at a center of toroid of mean radius 10 centimeter with 200 turns and carrying a current of 2.5 ampere. See, if you look the question carefully, you can answer it directly without calculation. So listen, so magnetic field at the center of toroid is given, center of toroid. So center means obviously it is 0. It is 0. You can answer directly if it is asked center of toroid. Okay. Next question. Yeah. So read the question, like the property required for a material to be used as a core of electromagnet are. So the given option are high permeability and high retentivity, low permeability, low retentivity, then high and then low, then both are, low and then high. So first one is, option is high, high, both are high. So what is permeability? So meaning of permeability is nothing but which allows the magnetic, okay, magnetic effect, okay. Then high retentivity, like when the current flows, the magnetic effect will be there for the property, but if the current doesn't flow, it should not be there, no. But in high retentivity, after the current cut off also there will be a magnetic effect, okay. So this option won't come. Next one, low permeability and low retentivity. So low, like this one should be low only, but low permeability should not be there, like it won't allow the magnetic field lines, okay. So first thing is I should be there and then low retentivity should be there. This is the thing we have got. So high permeability and low retentivity, so it allows the magnetic field lines, and if even the current gets off, the magnetic field line doesn't passes, okay. So this is the correct option. We will go for the next question. Yes. So what is the question number 111? Okay. So what is given in the question? A train is moving with a speed of 198 km per hour. If the distance between the rails is 120 centimeter and the vertical component of the Earth's magnetic field is 0.25 into 10 power minus 4. The induced EMF between the end of the axle of a train. Okay. I can calculate, no? EMF formula we know. Yes, pen came. Okay. So EMF is equals to B into L into and then the like speed, that is it, BLV. Okay. So, what is the given thing? B is given, the magnetic field is given 0.25 into 10 power minus 4 and the length 120 centimeter, no, change it into meter. So, it is 1.2 meter and then the speed is given in terms of kilometer per hour. So, 198 into 5 by 18 for meter per second, that is 1 times 1 and then 1, 11 times, right. So, into 55, into 55, am I correct? Okay. So, 0.25 into 1 point, I will write it 25 into 12 into 55 into 10 power minus 4 divide by 1, 2, 3, 10 power 3. Okay. So, only the calculation is left out, you can do it. So, from this I can calculate the EMF. So, the final answer is 1.6, the third option. Okay, we will go for the next question. Yes, a resistor of a resistance 160 ohm, an inductor of inductance 280 and the capacitor are connected in series to an AC source of 80 volt supply and 50 hertz frequency. If the circuit is in resonance, then the potential difference across the capacitor. See, I will give a hint for this question, you can try it out, okay. You can give the answer in the comment boxes. So, by tomorrow we will solve this question, okay. As the time is completed, no, next class is there, okay. Okay. So, inductance is given and the capacitance is given, inductive XL and XC, we know the formula for both of them, inductance and capacitance. Okay. What is the one thing we should note it here, like it is in the resonance. Resonance means nothing but both are equal, capacitance and inductance are both are equal. So, by calculating this, like for inductance they have given, for capacitance they have not given, no, but they asked the answer for the potential difference across the capacitor, am I correct? So, I can use this formula and I can find what is the answer for that, and I can use the same answer for the capacitance also. So, by that I can get the answer, okay. Let us give a try for this question, we will see in the next class, okay. Fine guys, bye bye.